Even though I'm not a Canadian, I got sent a Canadian phishing email today. And the perks of working in cybersecurity is you can take a look at what they're doing, trying to understand it, and then potentially, hypothetically, annoy them. We're inside a Kali Linux virtual machine, which means we can play around a little bit and see what they're actually doing. Looking at the link they sent me, it appears to be a landing page for a login form that is kind of trying to imitate a Canadian ISP. I'm not Canadian, so I won't know, but this looks like it's something like Telecom or Vodafone. The page that they link to is just your boilerplate login form. But with a lot of these scamming pages, you can find out a lot about them if you just look under the hood. So by using your very high-tech hacking tools, you can basically just inspect the source code. It is basically just pure HTML with some plain script JavaScript at the end. Taking a closer look at the JavaScript itself, there are basically two things that are pointing out. The first thing being a hard-coded URL and credentials to some service called email.js. I never heard of that myself, but after looking it up, it's basically some JavaScript library that allows you to send emails directly from your code. So this block basically will just send the credentials that are being entered by the victim and sends them to their inbox. I don't know how email.js handles it, but it's probably going to the attacker. And if this request is actually successful, so if the response is okay, they throw an error on purpose, which just says error authenticating reCAPTCHA. So this is probably a thing to just throw the victim off and let him think that something went wrong. But after the alert box pops, you will get redirected to a Grabify link. And for people who don't know, Grabify is basically just a website where you can redirect to an URL and you grab information about them, like IP address, their screen size, their operating system, their browser. They're just fingerprinting you. Also, looking at comments like these, this is a high probability that this entire thing was coded with AI. So 10 to 15 years ago, we had script kiddies. Now we have vibe kiddies. And with a website like Where It Goes, we can actually see where the link is going without leaking our own IP address. So we basically just have a 301 redirect to the actual webmail.bell.net website, which is, I think, just a normal login page. This looks like a way better and more modern version, and they actually have a CAPTCHA. So where you would normally go from here is you would actually try to log in with emails and passwords and look at the network tab and probably see a post request to some endpoint where your information is then sent over to the attacker. But because I don't want to leak my own IP address by clicking through the entire attack chain, we can do it in a way easier way thanks to the AI slop that the attacker used. So to actually annoy the scammer, we just need Python, Vim, and some basic standard libraries. We just start off by basically importing the packages that we need, a request to send requests, random to create random passwords, a string so we can create characters in the password and time, because we want to have actual control over how much and how long we're going to send some information to them. For the program to actually know where we are sending our information, we need to import the API endpoint, which we found on the client side, and the service template in user ID, which we also found there. I just took a look at the documentation. I don't really know what each of this is for, but we need to send it so the attacker is actually receiving the emails. And last but not least, we need to create some first names, last names, and domains. So this is actually just data that's randomized together to create realistic looking emails. And to actually create random emails, we just create a function called random emails, and we give it all the data that we have declared above. So we take a random first name, random last name, and maybe append a birth date to it, just to make it look a little bit different each time. The password is a bit more straightforward. We just create a random 12 character long letter, digits, and special characters based password. The attacker could maybe filter for password length if we're gonna spam him with this fake information, but this is just a proof of concept. You could take this a little bit further, randomize the password lengths, randomize the emails even more, use multiple proxies to send these emails. But this is just a proof of concept, and we are going on a very thin grade of we are actually allowed to do this and we are not. And I also don't want to annoy the people at email.js with too much traffic, but this gets the point across. Reading through the documentation of email.js, I found out that we cannot just send this from our client. We actually have to send the referrer in the headers as well, so that email.js is actually allowing us to go through. So we will just set the webmail.versal.app, and then we should be good to go. To combine the random email, the random password, the header, and the payload, we basically just create a function called sendFakeRes, which is going through the URL and just sends out a randomized pattern-based email password to the endpoint. And last but not least, we just create a loop, and while true, we send out the credentials and create a little print statement so we actually know what's going on and if we're actually successful hitting the endpoint. So if I didn't screw anything up in here, we can actually try to fire this up and see what we're doing to the endpoint. I will not let this run indefinitely, but let's see if it actually works. Firing this away. So looking at the output here, it actually works as expected. We're creating a different random emails, j.miller@gmail.com with a random password, and we actually get a response code of 200 back, which is a-okay. We can let that run in the background for some time because I still wanted to show you how it works under the hood. I actually intercepted a little post request earlier to see how we actually trying to hit the endpoint. The post request is pretty straightforward. It's actually what we're doing in our script itself. We set the host, the user agent, the refer, which is very important, otherwise we would not be able to hit the endpoint and get a 4 or 3 forbidden. And then you have the actual data that you send. Of course, our script in this case is actually randomizing this, and your response is 200 okay, which means we're actually hitting the endpoint. And just like that, we're probably ruining his day. I don't know if we're ruining his day, but we're probably ruining his inbox right now. We're still getting 200s, so we're actually sending a lot of fake credentials to him. It's beautiful to see. I will stop this soon. You could potentially make this with a better language than Python, because Python is not the best optimized for this. We can actually use proxies to send it from multiple addresses, but to be fair, you would basically just annoy email.js and not the attacker himself. So the best case scenario that you actually do here is to go to Vercel, and we're just going to report the URL and send an email to email.js and saying, hey, your service is used for that, and that's the best you can do anyways. This is just annoying him a little bit and having fun without overstaying our welcome in their server. This was a very random and spontaneous video. I would like to post some more stuff about cybersecurity. So let's see where this video goes. If it ends up with 2 views or even a little bit more, maybe we can get up to 10. But if you ever got some interesting phishing emails, you can just write it in the comments, because I would like to look at more of them, because I like to look under the hood and maybe explore together how we can annoy them and potentially break their campaign.